Welcome to today's tutorial on RNA extraction, where we'll introduce an efficient and simple method for isolating RNA for the challenging cell and tissues. Hope you've had some prior experience with RNA extraction. But first, let me ask you a couple of questions. Do you need to isolate enough RNA from macrophages and microglia, or other limited starting material? Or perhaps you're working with skin or muscle tissues, and you're aiming to isolate high-quality RNA. If you responded affirmatively to any of these questions, you've come to the right spot. Over the next few minutes, we'll lead you through a method designed to tackle the challenges associated with RNA extraction from macrophage, microglial, muscle, and skin cells. Sometimes you may need to extract sufficient RNA from a limited sample. This method not only addresses these challenges but also guarantees reliable and reproducible results. Let's begin with the initial segment of the protocol: homogenization of samples, specifically focusing on macrophage and microglial cells. Remove the medium from your cell culture and wash the cells with PBS. Be thorough and make sure to completely aspirate the PBS. For direct lysis, it's time to add the appropriate volume of trizol directly to culture plate. Use 1 milliliter of trizol per 100K to 10 million cells. Then collect the lysate from the cell culture dish or plast. Transfer it to a microcentrifuge tube, pipe it to mix, and ensure no cell clumps. You can either proceed to the next step or keep this lysate at -80 degrees Celsius for extended periods. According to the manufacturer, this homogenate is stable for at least 1 year at -80 degrees Celsius. Let's move to the homogenization of tissues such as skeletal muscle or skin. Begin by obtaining a small tissue piece, weighing less than 30 milligrams. Immediately transfer the tissue piece into 1 milliliter of pre-chilled trizol. Now, grab your scissors and let's mince it up. Transfer all the sample to a pre-chilled Dounce tissue grinder. Gently homogenize the tissues by moving it up and down more than 10 to 12 times. Then transfer the homogenate to a new tube. Like what mentioned in previous slide, you can either proceed to the next step or keep this lysate at -80 degrees Celsius for extended periods. According to the manufacturer, this homogenate is stable for at least 1 year at -80 degrees Celsius. Following the homogenization, it is the phase separation. Step 5. If your lysate was frozen, it's time to thaw it out. Place the lysate at shaker with low speed for 1 hour at room temperature. Step 6. If your lysate is fresh prepared, let's incubate the lysate for 5 minutes at room temperature. If you've pre-chilled the trizol, extend the incubation to 15 minutes. This step is crucial. It allows the complete dissociation of the nucleoproteins complex, a bit like unraveling a tangled puzzle. Step 7. In the chemical fume hood. Add 0.2 ml of chloroform per 1 ml of trizol reagent. Securely cap the tube, give it a vigorously shake by hand for 15 seconds, and incubate the samples at room temperature for 3 minutes. Step 8. Centrifuge the samples at 12,000 xg for 15 minutes at 4 degrees Celsius. This will separate our mixture into a lower red phenylchloroform phase, an interphase, and a colorless upper aqueous phase. The RNA, our prized treasure, stays exclusively in the aqueous phase. Step 9. Transfer the aqueous phase containing RNA to a new tube. Angle the tube at 45 degrees and pipette the solution out. Be careful not to transfer any interphase or organic layer into the pipette. In most cases, half of the aqueous phase is sufficient for downstream applications. Following that, we will continue the procedure by following the RNA kit manual. Below is the connection step. Add 1 volume of 70% ethanol to the cleared lysate and mix immediately by pipetting gently. From this step, please follow the RNA kit manual step by step. If you found value in this scientific journey, show your support by giving it a thumbs up, subscribing for more experiments, and ringing that notification bell. Feel free to drop any questions in the comments below. Best of luck with your experiments.